11. Oof. We'll try. All right. So what's so we're doing the you're still driving, you're still coding. I'm just gonna tell you. I'm gonna make a ton of fun comments on the side. Exactly. All right, cool. So let me okay. Nice. All right, let's get into it. Yeah. Whoops. All right, hold on 1 second. 1 second, 1 second. We're having audio issues again. Surprise, surprise. Wait, maybe not. I don't know. I'm not sure. Hold on, I like totally changed this. Whoops, let's do that. Okay, can you speak, Martin? Audio's good now. Okay. All right, cool. Phew. Oh, wait, hold on. Martin, you can't hear Martin. Martin is... I hear Martin. All right, hold on. No, I still hear you. I think it's a... let's see. Come on. I think it's these, like, remember we had the issue the different audio channels. I don't know why you would be muted though. We didn't change anything. I think so. Let me see if... I am not a Soundflower driver. I don't know what that is, but we were using I Show You. That is open, right? Yeah. Oops. Where'd you go? Yeah, I show you still working. Oh, now it's gonna screen record. Oh wait, no. Oh wait, hold on. Can you hear Martin now? Multi-output device. Nope. This is so weird. Sunflower, okay. Yeah, for another time. Martin, just keep talking. I'm gonna change these, like, because I think it's just the tracks that we have. Oh, now we heard you.
Oh, really? It's the humming. I should just hum.
And we have Martin. There we go. Yes. Awesome.
Well, what did you do?
It was the tracks in OBS.
Oh, okay.
I don't know. Something happened where you hummed and it just put you straight into it.
Jumped right into the perfect channel.
Yeah.
And yeah, it's humming.
It's definitely the humming.
Humming is deadly. So now let's continue.
Please, I'd rather
have me switch off. Then hum all the way.
Let me download Sunflower really quickly. Anything to make this humming stop. All right. Cool. So we're good now. Great.
Okay.
Let's do it.
Let's do it. All right. So I'm gonna say this really quick once again, which is pet breeds. This is gonna be really quick. Pet breeds today because we're on lesson 5. We already did a pet breeds classifier when we didn't know that there's going to be a pet breeds. Well, we did a dog breed classifier when we didn't know there's going to be a pet breed classifier coming up. So we thought we're going to go over this lesson now, the pet breed classifier lesson, and just compare to what we did initially and see what we did wrong and what we can improve on that initial lesson 2 thingy that we did. Right? Agreed? Yep. Cool. And we have that thing finally deployed and working. So you can go to this GitHub page, GitHub repo, dog voila, and then click on this launch binder, launch, and then classify whatever you want to classify. I mean, really, it's just going to work on dog breeds, but also it's going to give you what's the dog breed most closely related to whatever you put in. Like this cute cat is a Brittany Spaniel. That's all. Close. Seen enough. Let's get started.
Let's do it.
I imported the dependency stuff already, so we can just get started reading and doing stuff. Nicholas, please take it away. Image classification.
Let me just really quickly.
Okay, I take it away. Image classification. Wait, I can't.
Okay.
I also mentioned that I'm in a slightly bad mood today, but I'm already in a better mood. Just
the power of humming.
Nick,
humming for the win again.
Nick, before I start, I just need the audience. I need the claps. All right, whatever. Stop being stupid, Martin. Now that you understand what deep learning is, what's it for, and how to create and deploy a model, yes, it's time for us to go deeper. Oh, I thought that's what we did in the last 7. In an ideal world, deep learning practitioners wouldn't have to know every detail of how things work under the hood. But as yet, we don't live in an ideal world. The truth is, to make your model really work and work reliably, there are a lot of details you have to get right and a lot of details you have to check. This process requires being able to look inside your neural network as it trains and as it makes predictions, find possible problems, and know how to fix them. So last stream, together with Gilad, we did kind of this quite a bit. We looked into the different fitting methods that fast.ai uses. We're just trying to understand what are the different attributes to it. And Gilad was pretty helpful because he actually understands this stuff somewhat. So that was nice to have him on. Excuse me. So from here on in the book, we're going to do a deep dive into the mechanics of deep learning. What is the architecture of a computer vision model, an NLP model, a tabular model, and so on? How do you create an architecture that matches the needs of your particular domain? How do you get the best possible results from the training process? How do you make things faster? What do you have to change as your dataset changes? And the type of it. We will start by repeating the same basic applications that we looked at in the first chapter. Oh, but we are going to do two things. Make it better. Well, yeah, exactly. That's what we were trying. Make it better, apply them to a wide variety of types of data. In order to do these two things, we will have to learn all of the pieces of the deep learning puzzle. This includes different types of layers, regularization methods, optimizers, how to put layers together into architectures, labeling techniques, and much, much more. We're not just going to dump all of these things on you, though. We will introduce them progressively as needed to solve actual problems related to the projects we're working on. Okay. Nick.
Cool. I'm going to request remote control.
Take it. You shall have it. Here you go.
Cool, because I can't read. I have our faces on the side.
Oh.
So, all right. So from dogs and cats to pet breeds. In our very first model, we learned how to classify dogs versus cats just a few years ago. This was considered a very challenging task, but today it's far too easy. We will not be able to show you the nuances of training models with this problem because we get a nearly perfect result without worrying about any of the details. But it turns out that the same data set also allows us to work on a much more challenging problem, figuring out what breed of pet is shown in each image. In open close bracket, we presented the applications as already solved problems, but this is not how things work in real life. We start with some data set that we know nothing about. We then have to figure out how it is put together, how to extract the data we need from it, and what that data looks like. For the rest of this book, we will be showing you how to solve these problems in practice, including all of the intermediate steps necessary to understand the data that you are working with and test your modeling as you go. We already downloaded the pet data set. Okay. And we can get
we did that some other time.
Yeah, a path to this data set using the same code in. Okay. So, interesting. So are we training breeds on this same pet data set? I guess so.
I think so.
Okay.
So it's a different data set though than the one that we used for the dogs, but it's the same that we used to classify cats and dogs.
Yeah. So actually, yesterday on Twitter, I saw this this person. What did they tweet? It was watching your models get more accurate in real time on like a graph. So it was a plugin within Jupyter Notebook, or like you just call this. We could go on Twitter and grab the link, but it was a GitHub repo that plots the accuracy of your model as it's training, which is pretty cool.
So in the same way that we getting the outputs of the numbers, it just makes a graph instead.
But in real time, we don't have to wait until the end.
Don't we? Anyway, like not on a per epoch basis.
I didn't look into the repo, but the GIF that he put up it seemed like it was pretty like seamless as it was like moving. It could have been sped up or done on a model that was training where it was like half a second per epoch or something, where ours are 47 seconds or like a minute or something. But yeah, I don't know, we could, once we're there, we could take a look at it.
I'm just thinking about it. Yeah. But I think it cannot, like from my current understanding, I think it could only be on a per epoch basis because the
I don't know.
numbers only exist at the end of the epoch, right?
Yes.
There's no result before the epoch is over.
Yes. But I don't know. I didn't look at the repo and see like, is it? He said like it worked with PyTorch and Keras, so I figured fast.ai is built on top of PyTorch. Maybe.
Keras.
Yeah.
How to pronounce Keras? I thought it's Keras or Keras or something. In biblical Greek, Logos Bible software. It's not really.
Oh, it is. Yeah. Okay. So it is. Keras.
Oh, you know that.
Yeah.
Keras. What does it mean? Mr. I speak Greek.
What was that? You kind of broke up.
What does it mean, the word?
I mean, it says it right there. Horn.
In Greek.
Horn.
Oh.
Moving on. Do you want to...
Now if we're going to understand how to extract the breed of each pet from each image, we're going to need to understand how this data is laid out. Such details of data layout are a vital piece of the deep learning puzzle. Data is usually provided in one of these two ways. 1. Individual files representing items of data, such as text documents or images, possibly organized into folders, or with file names representing information about those items. Or we get a table of data, such as in CSV format, where each row is an item, which may include file names, providing a connection between the data in the table and data in other formats, such as text documents and images. Okay. There are exceptions to these rules, particularly in domains such as genomics, where there can be binary database formats or even network streams. But overall, the vast majority of the data sets you'll work with will use some combination of these two formats. I have a question for Thickfunk in the chats. Are you using any sorts of like genomics data? Because you're working with health data, as far as I know. Is there like anyone doing genomics machine learning analysis on the kind of data that you're working with? Unless that's like secret or something. just wondering.
Super hush hush.
Super hush hush. All right. To see what is in our data set, we can use the ls method. Path.basename equals path.ls. What do we have? We have 2 folders, annotations, and images. And where is path? It does have that. /content. Exactly. So this sits G drive. No, not G drive. Where are we?
We're in content.
We're already in content. Okay.
Yeah. So
there we are.
Content,
okay, content.
And then it's my G drive, right?
So why is this saying that inside of content we have annotations and images if it's not there? You see what I'm saying?
Yeah. Go into my drive.
I mean,
no,
that's
data.
just our notebooks.
That's
data is a folder that we made for some of our content.
Right. Okay.
Yeah. Good naming makes it sound professional. Yeah, so that's weird for me. Why? So we're supposedly here, right? We're supposedly in /content on the GPU, and then we should have 2 folders in there, but for some reason they're not showing up. So let's try whether we get the same thing if we do G drive sample data. So
what? Yeah.
I guess this is going somewhere else, huh? What is this path? Untar data. URL.pets. So we got some fun stuff going on here. Doc untar data. Where are we really? Tell us. Untar data. URL, file name none, destination none. Download URL to file name if destination doesn't exist, and on digits or unzip to folder destination. Oh, so I remember something doing actually here in this Dogbreed notebook. Look at this note. There might be a more elegant way to download and untar data using a dataset using fast AI functions. And then we did it with wget, and here's the function. It's called untar data.
Okay, but where does it put this?
Where does it save it? We're not giving it a. So we're giving it. I guess this is the URL. URL.pets. Let's see what that is. URLs.pets must be some sort of web address, I assume. Yeah. Okay. So this is where the data is hosted.
So Oxford IIIT pet.
Yeah.
I wonder how. So I wonder how. I guess it's the Oxford data set versus the Stanford data set.
Battle of the Giants.
Because I imagine the rest of it's going to be the same way, right? Like, we're probably.
But the thing is, like,
in a similar way, and I mean, I could be wrong.
No, the thing is that the Stanford data set we were working with is only dog breeds. I think this is all sorts of pets.
Sure.
So it's going to be a bit different.
Okay.
But I'm still confused because we're not giving it a destination, right? We could give it a destination and save it somewhere else.
Let's scroll down a little bit. See what else we got in the notebook.
Yes, sir. We can see that this dataset provides us with images and annotations and images and annotations directories. The website for the dataset tells us that the annotations directory contains information about where the pets are rather than what they are. In this chapter, we will do classification, not localization, which is to say that we care about what the pets are, not where they are. Therefore, we will ignore the annotations directory for now. So let's have a look inside the images directory. No further mentions so far. We're just inspecting deeper into where we don't know where we are. Images rectal. Okay. Whoa, you.
Me. I'm gonna start looking for this.
Yeah, I assume it's kind of, I assume it saves it somewhere into some fast AI, like when you install Fastbook or something, maybe it sets some, wait, can you scroll up? Actually, there was this base directory that we're using as a variable in the code.
Yeah.
Maybe you could check what base path, what that is. I think you gotta do path objected, yeah. No, yeah, that would work, but there you go, nice.
So, do we have we do have, so here. Interesting. Oh, because it's hidden. It's a .fastai/data, so it's not gonna show up.
But you should be able to just ls it. Like if you do this exclamation mark, you can run bash functions, or like a one cell up. Or like
okay.
If you just do cd or /root, or actually dot, I guess you gotta go one level up if this starts in content.
Yeah.
No. Yeah. Okay. And then ls-al. Dot fast AI. Here we are. Okay.
Okay, then we have all this other stuff too.
Okay.
Mission
looks like
accomplished.
That's where it's Mission accomplished.
Mission
Thank you.
accomplished. Yep. Okay.
I feel
So
calm.
we're here, right? Most functions and methods. Or did you just read this?
Mhm.
You read this?
No.
Okay.
No.
Okay, let's clean that up. All right.
A little more up.
Yeah, it's just laggy.
Yeah.
Okay. Most functions and methods in fast.ai that return a collection use the class called L. L can be thought of as an enhanced version of the ordinary Python list type with added conveniences for common operations. For instance, when we display an object of this class in a notebook, it appears in the format shown there. Okay, so the one that was just, I guess, this? No.
Yeah, I think that output.
Yeah.
That's what it's talking about.
Okay. For the first thing that is shown is the number of items in the collection. Got it. Oh, okay, I didn't see this. Yeah. Item in the collection prefixed with pound. If you'll also see in the preceding output that the list is suffixed with an ellipses. This means that only the first few items were displayed, which is a good thing because we would not want more than 7,000 file names on our screen. By examining these file names, we can see how they appear to be structured. Each file name contains the pet breed and then an underscore. Okay, a number, and finally the file extension. We need to create a piece of code that extracts the breed from a single path. Jupyter Notebooks make this easy because we can gradually build up something that works and then use it for the entire data set. We do have to be careful and not make too many assumptions at this point. For instance, if you look carefully, you may notice that some pet breeds contain multiple words, so we cannot simply break at the first underscore character that we find. To allow us to test our code, let's pick one of these file names, okay?
Something I noticed, can I show you this quick?
Yep, go for it.
So up here, you remember we were using the same data set here in the cat classifier stuff? No, not in here. In the actual first notebook where we just did the cat dog classification. And our label function was what's the first, what capitalization is the first letter of the file name. So it was like if it's
correct.
If it's
so
lowercase,
that's a dog. Capital is a cat.
Capital is a cat. Right. Exactly. Yeah. So here we also actually see a little bit about that.
Yep. Yeah.
And so which again means that this classifier, if we use that same data set, is actually only going to classify cat and dog breeds, dag and cod breeds, cod, different type of fish.
What do you mean?
It's not going to classify any sorts of, it's not going to classify hamsters or bears or whatever.
Oh, sure. Yeah.
Right. It's just going to be cats and dogs. Yeah. I thought that maybe the data set has all sorts of different, chameleon brands.
Sure.
Brands of
I don't know that. Are there multiple breeds of hamster?
I believe so. Hamster breeds, I'm sure.
Can you name a few hamster breeds off the
Give me a second. Of course I can. Look at me do it. I'm your neural network.
Roborovsky.
Hamster, less fluffy hamster,
Campbell's.
Syrian, cream-colored Syrian, long-haired. See, I knew there was a fluffy one. There's always a fluffy one. Roborovsky, Chinese. In the winter coat. Okay, anyways.
Super
okay,
cute. All right.
So I just thought that was interesting because I just saw it here.
Okay, so all right, we ran this. The most powerful and flexible way to extract information from strings like this is to use a regular expression, also known as RegEx, or RegEx, as some people. This is like tuple or tuple. We're back at it. Tomato, RegEx, RegEx. A regular expression is a special string written in the regular expression language, which specifies a general rule for deciding if another string passes a test, i.e. matches the regular expression, and also possibly for plucking a particular part or parts out of that other string. In this case, we need a regular expression that extracts the pet breeds from the file name. Okay, I'm not going to touch that. We do not have the space to give you a complete regular expression tutorial here, but there are many excellent ones. Okay, scroll. It's just talking about tutorials, and then click that link. Not only are regular expressions dead handy, but they also have interesting roots. They are regular because they were originally examples of a regular language, the lowest rung within the Chomsky hierarchy, a grammar classification developed by linguist Noam Chomsky, who also wrote Syntactic Structures, the pioneering work searching for the formal grammar underlying human language. That's pretty cool. This is only one of the charms of computing. It may be that the hammer you reach for every day, in fact, came from a spaceship. All right. So when you're writing regular expressions, the best way to start is just to try it against one example at first. Let's use the findAll method to try a regular expression against the file name of fname object. Okay, so let's go ahead, run that.
Also,
do you want to pull up RegEx? Yeah, RegEx 101. I use RegExer.
RegExer, I also like that one. RegEx. And then you can play around with the test string. Our test string, I guess, would be those file names. So it's a pretty nice way of.
Whoops.
Can I just?
Oops.
And then we'd want to grab this stuff. I think another way to do this actually that would be easier is to just split it up at the slash, and then fetch everything up to the dot. Like you could just do a string.split with Python. No need to use RegEx, but anyways. So we would want to match a word, which is \d, which is that's a digits. Okay, so that's we would have so W is the word followed by a digit, and includes the underscore already. So, and then we want to have at least one or more. Like that should do it. Looks good, right? So this would fetch them. But yeah, so these tools, same over here.
So what do we got here? It's
Do you want to build it too? Or was it already there?
No, that's well.
Okay, not really.
Yeah, sort of. I mean, go back to that one, and we could like quickly just compare the differences, right? So just undo that one. The only thing this is just grabbing is path, but path is not going to be. We're not going to see it. So this is doing a capture group, right? Of
capture group.
The parentheses are a capture group of the character set. So match anything in that, and then.
I'm surprised though that it takes the underscores. Shouldn't they not be part of this? It is that, like this, because here when we do the \W, it matches any word character equal to A to Z, 0 to 9, or underscore. So we don't even need this.
Right. That's the point in the other one is
to stop it from matching these things.
Matches any.
Because here it matches.
Matches everything.
Digits. Yeah. So it just doesn't match the dot. But if we say it has to be a word character followed by a digit, if we know that it always ends with a digit, then it's only going to match these.
Right. But again, like it's not matching the word path when we run it on the list. Here it is because that like the word path was printed out with all this other parentheses and stuff. But once we're doing it, like once we're looping through it, we don't need any of like this works. Just the /w+ works.
Well, the slash just this one wouldn't work because then we would match the JPEG.
Oh, what was it before? Oh, just slash.
So it
Go
works
back to
if
the
you
other one. Remove the plus or something. No. The plus you need. What was in RegEx 101?
The point here is just that we have two capture groups, and that the first one is like any word, and then the second one says it has to have a number at the end. I think. Does that make sense? Like this can be split up in two capture groups, I guess. This one makes less sense to me than this one. Here I'm like, okay, I want at least one word.
So I think what's happening here is so if you remove the D, like the slash D plus,
back to the same. Yeah.
It still gets right, but it'll remove
because
the JPEG,
includes,
right? What's happening in the other one is you're doing the whole like A through Z thing, and then you're just stopping at the period. You're stopping at the dot, right?
Mm-hmm.
But I wonder why it's not grabbing JPEG.
Yeah, see this.
This is literally wasn't I telling you this yesterday or 2 days ago when I was building a like search and replace thing in Go, and I'm like, I need to take a RegEx course or just a RegEx refresher because there's so.
Yeah. But this really isn't like, this is a weird one because this just matches uppercase characters, as you see here. Like,
oh, maybe that's why it's not grabbing.
A bunch of, but not anything else.
Right. But if you put that slash W, it's the whole word. It's not going to match the period. And then in this case, it's not matching JPEG because JPEG's under lowercase.
Yeah, so it doesn't start again. Correct.
Yeah. So
this says anything that starts with a, but then, yeah, right, there you go. Okay.
Yep. So this is actually only going to get cats.
That's a cat. Yeah, that's a cat finder.
Yeah, here's your cat finder. All right, so I think we should go with the slash W plus slash D.
And then slash D. That makes more sense, yeah.
And that'll grab.
I think it should get them. It seems to get the dog, and it seems to get the cats too, and the pug.
Cool.
Okay.
Let's see what their solution is.
Right. File name. Let's pick one file name. All right. Let's print it. I want to see the file name.
We should just do like a whole thing on like really obscure Nick and Martin learn RegEx. And it's just like the weirdest. We just try to figure this out. But we match like really weird text.
Okay, the most powerful and flexible way to extract information from strings like this is to use regular expressions, also known as RegEx. Did you just read this? In this case, we need to read this.
Yeah, scroll down.
Yeah, book size. Okay.
Here, so we got.
Find all. Okay, so they're using any character, at least one or more.
But they're grabbing the JPEG, right?
Followed by an underscore, yeah. And then a digit. Followed by an underscore and then a digit.
No, the digit, the period is kind of like, I think, anything.
Here, yeah. Yeah.
So it's that first capture group of like anything up to that underscore.
This is weird because this digit would also be like that should be escaped if they actually mean a dot. Like you should do slash dot.
I mean, run it. Let's see. It should obviously work.
And this dollar says that it has to end with this JPEG thing. But
so maybe that's why they don't have to escape it.
Seems kind of messy to me.
Oh, they're. Okay, this makes sense because they're only capturing the name. They don't want the number. We're capturing the number.
Okay, so they're excluding the number. I see.
So capture group.
Dot is still matches any character, so if they
maybe it's just the way that Python,
it seems like it's not parsing it if we run it here. I checked with Python.
Interesting. Okay.
Let's try it in here too, actually. Let's see. There must be some different interpreters. Yeah, it doesn't match.
Mm-hmm.
So capture group 1. Any character followed by an underscore, then a digit. And it's making a capture group, which just means that this is something we can pick out later if it would match anything.
Yeah, go back into yeah. Okay, and then it's just fname.name. Oh, never mind.
That's a
yeah.
weird one. It's weird because it means this means any character, at least one or more, that should be the first capture group. So this could be anything. And then it should follow by an underscore, which is I think how they are, right? They follow underscore and then a digit.
Yeah, it's on all of them, it's always underscore digit and then the file extension.
Okay, so match anything that is preceded by an underscore, a digit, at least one or more, and then ends with .jpeg.
Yep.
Makes sense? And then we pick out the first capture group, which is going to be just the name. Mm-hmm. Okay. Interesting that it doesn't work on our nice visualizers.
Can you do, just so like it's, because this is kind of messy too.
I know why.
Can we do another one?
Can I just show you quickly?
Yeah.
I know why it's not working. Because it's assuming the end of a file, at the end of a string,
mm-hmm.
with this $. So see, now it's capturing it. And now it's capturing it, any character. This all matches any character up to an underscore, a digit, .jpeg. So we have 2 capture groups. The whole thing matches, and we're gonna pick the first one. And we're gonna iterate over it inside of the images directory. So it's gonna look like this.
So
and then
so the $sign is end of a string.
End of the line. You see?
Okay. Can
it
you?
needs to be at the end of the line. Otherwise, if I do this, then.
Right. Hold on.
Yeah. You see?
I'm gonna try some. Can I try something?
Texas.
So if if you remove this, it'll capture it. Okay.
Yeah.
Got it. Okay.
But then it takes everything as well.
No, I know, but this makes it clear. Yeah. Like this shows the whole, the power of this regular expression. Got it.
Mm-hmm.
Okay.
Cool. So this regular plugs out all the characters leading up to the last underscore character as long as the subsequent characters are numerical digits and then the JPEG file extension. Now that we confirmed the regular expression works, for the example, let's use it to label the whole dataset. Fast.ai comes with many classes to help with labeling. For labeling with regular expressions, we can use the RegExLabeller.
Sound is gone.
Oh no. Is it?
Can you hear both of us?
Not.
Can you not hear both of us?
I imagine if there's like more people watching this more often, they're just gonna start trolling us with saying that the sound is gone.
Seriously, right? Someone from the beginning is just gonna.
Hey, your sound is gone. And then watches like try to scramble for figuring it out.
At that point, that's when we get a moderator. That's like outside watching this, making sure that everything's working.
So what do we, should I keep speaking? Blah, blah. I'm going to do something else. I'm going to undress my pullover because I'm too warm.
Well, you have to keep talking.
Okay, blah, blah, blah. I can talk while I undress my pullover. That's
okay.
Positive. I have my microphone here. And I will continue monitoring how I take off my pullover, which is pretty warm. And we're still going, still on task of undressing a pullover, which is very challenging, but I'm about to succeed and nearly there. So I managed to undress my pullover, cover me, and I'm about to plug back in my earphones. And now I can hear you again, Nick, maybe. Just like anyone else, maybe can hear us. And probably not.
Hold on.
I'm holding on. I wonder, yeah.
Oh wait, wait, I think all the sound is gone.
Oh.
Interesting. I wonder why. Speak.
I'm gonna try humming.
Yeah, hold on 1 second. All right, let's just like blah blah blah.
Let's hum.
Hold on. I hear it.
Yeah. I can hear it too.
Yeah. I hear.
So it is trolling. Can you say something, Nick?
I think we have our first troll.
It worked.
Or maybe, I mean, it could have not been working, and now it started working again.
Maybe.
All right, well, if it's working, let's just continue on.
Okay. Nice one, though. Well,
Still no sound?
Maybe switch on you. Do you have maybe yourself?
Oh man, did you press mute on the video? Well, he can't hear me, obviously. If
Yeah, you tapped that. Yeah, these videos tell him that these videos have a tendency to mute themselves. Oh.
we need to have like our own emotes.
A troll award?
A troll emote. Unless maybe it's already in Twitch and then we're just not. The video muted itself.
Wait, that's
wonderful.
So, did you just have your video muted all the time?
The video, I guess, like muted. Yeah, like maybe if you're not watching it.
Maybe then it mutes automatically. Right?
Maybe, yeah. Which tells
You've
me
been busted.
Yeah. Why aren't you watching it?
Well, I was even asking a question to you before, but maybe you just didn't hear it, I guess. Well, cheers. Here's some black tea.
Oh, he's sitting there talking.
See.
Do you want to ask that same question now? Now that the audio's back up?
Let me see. What was it? I wanted to know about genetic data, whether
is there any machine learning happening?
Whether there's any genome machine learning happening at your company? Because we were looking at genome, like I was talking about genome data. Oh, you did?
They did. Okay, well, maybe it's like HIPAA compliant or something. You can't really say anything.
Yeah, all right. Maybe that's when it automatically just silenced us.
Ooh.
Company internally.
Or not us, but it's silent. It like removed the
For
comments
him.
back from him.
Twitch censoring. I like it.
Oh man.
All right. Z.
Okay.
Z.
They do some stuff with NLP and that's pretty cool.
Fun. Yeah, I wonder, like genome data is probably interesting to work with.
Yeah, for sure. All right.
What libraries?
Oh.
Is it like TensorFlow or PyTorch, or something completely different, or fast.ai? Who knows? All right. Anyways, where was I? Was I somewhere or were you somewhere?
You were somewhere.
I was somewhere.
Yeah. Anyway.
So we did lots of funny regular expression stuff, and now we confirmed that the regular expression works. Let's use it to label the whole data set. Fast.ai comes with many classes to help with labeling. For labeling with regular expressions, we can use the RegExLabeller class. In this example, we use the data block API we saw in fact, we nearly always use the data block API. It's so much more flexible than the simple factory methods we saw in somewhere else. Pets. We're making the data block. What was that? Data block. Blocks. Which block? Category block. Oh, I remember. No, there was a data batch, data bunch, data loader, data block. Breathe.
Are you making sense of this now?
Sorry, what?
Are you trying to make sense of what's happening in this data block?
I'm just trying to breathe.
Okay. All right, let's go ahead and run that so that we get our data loaders. And so, yeah, so what's going to happen here is just splitting. Splitter is random splitter. Seed is equal 42.
So, Nick, look at this. So it looks like a data block has a data loader associated to it already, right? Because we're creating a data block object, and then we're saying .data loaders.
Yeah.
Around revelation.
Get items. Get image files. Is that?
That's a inbuilt function that I've.
Okay.
Yeah.
Okay. Yeah.
It's a nice one.
Let's just keep going. Okay. So here it's doing the whole like transformations and stuff as well.
Mm-hmm.
Okay.
So this it helps you from the path, and where it seems like the data block takes the path somewhere, right?
Mm-hmm. All right. So let's keep going. Let's
Where are we passing the? So I guess this is the interesting thing. Get y, which is how we're getting the labels, and it's telling us we get the labels using an attribute, and the attribute is going to be the file name, and on it we apply the RegExLabeller, passing in this specific regex that fetches just the name. Hey, so this is fun. So we can actually, let's do this. Let's.
Do you want to?
Because we wanted to apply this.
Yeah. Let's do it.
Right. Let's just apply it on the thing and then get rid of those annoying names that you hated so much the first time we went through it. Yes.
Let's do it. So excited.
I thought this is gonna make you happy.
Can we just peek into just peek into the ugly names at some point?
Of course we can. We can actually apply two things. We can update the download the untar data. We can do that and make this a bit nicer, and then also the second one.
Oh, sure.
For the names.
Yeah, that sounds good. Do you want me to hide this super secret code with our faces?
Yes.
I could do it on my side. I'll just put our faces over everything.
You ready? 1, 2, ready?
Yeah. Whenever you're done, you just gotta let me know, and I'll minimize our faces again.
No.
We still don't know what it does. Or if you can like reverse engineer and like get into our Google account.
Into our shared Google account.
But if anyone's interested, the auth code is publicly available on our YouTube channel in the first 4 episodes.
I think it changes, doesn't it?
It does change, right?
Yeah.
But yeah.
All right. We're done.
It's not on the screen anymore.
Not on the screen anymore.
Okay. Whew.
And we're mounted on content G drive. All right. Getting some images. Okay, this is downloading this couple of. We don't really need to do that, but let's do it anyways because it works so smoothly. Does it?
Yeah, I think it does.
Check the docs.
Okay.
Yeah. So this download images is also a nice function that I found when cleaning up. And now, part number 1. there might be a more elegant way to download and untar a dataset using fast.ai functions directly. Let's do it. I am excited about this. Well, I think it was just untar data. Or is it something as simple?
A little bit further up. A little bit. Right
there it is. Untar data. And then we can pass it the URL and then the destination if we want.
Mm-hmm.
And we're going to do something like that. Currently, let's see if we have a, what's the current path? Do we even have something? Path that second directory would be content. Okay, so let's say, I think yeah, doctor, I already defining that. Doctor is content G drive, my drive, data, doc-bit classifier. Perfect.
Mm-hmm.
So that's where we want to put it. So I say, not this, yeah, yes. Path. Doc-bit classifier. Let me just double check this real quick. G drive, my drive, data, doc-bit classifier, images. Okay, so this already has the data in there.
Yeah.
Yes. So it's kind of stupid to download it again, but let's do it because
let's download it again, and yeah, I think that's fine.
Onto our data, and here's our and the path is going to be, wait, how was that? We can pass
Doctor.
it dest. Okay.
Yeah, dest equals doctor.
Dest doctor. Okay. And then it seems it returns the path. Download URL. Yeah, looks like it returns the path because that's what they were doing with the other one.
Okay.
Nice.
Nice. All right, so
much more elegant.
yeah.
So we can get rid of this. And then we don't need to untar it.
Yep.
This is also already going to happen.
So do you want to just look at this and then open up like the regex tester, grab some of these? So from all of these, it looks like we just have to match, anything from that first dash on is the name.
It looks like, and yeah, which seems, honestly, it just seems an easy split. If we could even use Python for it, right?
Yeah.
Again, we could just say, split it up at the comma. I'm not going to do this for all, don't worry. Okay, so like this. And then we could say, get, whoops. Did you do it? No, okay. We want everything starting with a dash, but we don't want the dash. And then a word character, but without the dash. So we would make a capture group and then just pick the second one.
Yeah, and we just have to make sure that we're not including, I guess, the word it'll end on the period. Do we want the .jpeg? Because in pet breeds, in the fast.ai, they're using that name. No? Oh no, they're
so
discarding it.
These are folder names.
Yeah. Oh, that's right.
These are not actual images.
Right. So this was just to clean it up. What happened? What's the exception above? Something broke with the untar.
Unrecognized archive. Images.tar.
Maybe something with untar data goes into this fast.ai archive.
You mean if I don't do this? Well, let's see whether it downloaded it. It should be one level up. We found that before in root.
Yeah, but you have to. Yeah, it's
hidden,
gonna
right?
be hidden, and I that's what I'm saying. I don't think it may not. Let's see.
Where did it go? fast.ai archive. Images.tar.
Okay. And
Seems to be
what's
there. Unrecognized archive. Zip file extract tar file.open. If fname ends with .gz, if file name ends with .zip. So it ends with .tar.
Yeah, so it doesn't know what to do.
There's like a couple of different, there's a couple of different ways of tarring files. I know there's a tar.gz, which I think is the one that this one is looking for.
Which is funny because it's saying, like, the function
untar.
is untar data.
Yeah. Data external.pi. fast.ai data external.pi. Can I just check that whether there's more? What was it? GitHub. fast.ai. fast.ai.
Can't we just, in like a hacky way, just rename the file as like archive.gz?
Yeah, we could. I mean, we could do that, but
yeah, you do it the proper way.
No, I'm just thinking because that's what we're trying to do it the proper way. External.py. And then with gz, tgz, or what was the other one? Zip.
Yeah.
Or no, ends with. I'm sorry, I just want to find the right. fname.ends with. Okay, yeah, it really only has these two options. So that's why it doesn't find the tar. But that's interesting.
Okay, it just says tar file.open, but what were we doing before? Oh, we were doing it in bash, right?
But that's interesting because this should work, you just need to pass a different flag to it as far as I know. If like depending on which, did I delete it? Of course I did. Well, we still have it on our GitHub. I think you would just pass a different flag if it's depending on whether it's .gz or not.
For tar file.open, you mean?
Yeah, it seems like they're also passing something here. You see that?
Yeah.
I think that's probably an option, I think. I don't know this tar file.open.
So, all right, so let's say it's just a matter of passing in another, flag parameter or whatever to this function. What then? To this open function? Like
we could make a PR.
Are we okay?
If that's really the thing,
Yeah. So you want to like overwrite this function to try like tar file.open, because now that it's downloaded, right? So why don't we do that? What's
So here you see xvf is the ones that I had to pass to work with this type of tar file. But it's probably using the same type of untarring, I assume. And then our gz bash tar gz xvf. That's probably not the best search.
So
options.
Where is why do we need bash for this, right? We're trying to do it in Python.
Right, we don't. I'm just wondering what they are using here actually. How are they? I mean, they're just opening it.
So yeah, hold on. Let me. I just want to see something. too.
Yeah, you're right. No, you're right. It's a Python open.
Right? So like there should be some sort of like torch basics, import all, tar file is just 2. So this tar file seems like it's coming from torch basics or something, right?
Is it?
I mean, there's the only 2 places that it's defined, and then the import is just import all. So that's what I'm I'm guessing, right?
Yeah.
So if this is in torch basics, let's look at PyTorch tarfile.open and then see what other
good idea.
Because I also imagine this like R. So here, right, they're not passing anything, fname, nothing. So I imagine this could just be like R:tar, right? And we should just be able to, like, why don't we just copy this line, import everything from the same, like, from torch basics.
I think we might even be able to just do file extract. Yeah, okay, go ahead.
Yeah, because I don't know what this tar file is. Well, this is actually like, so this is a zip file. Okay, so if we just copy this into ours. So it's already downloaded. Let me just rearrange our faces really quick because it's blocking the screen. How do you make the error go away? Like, I just don't want to see it anymore.
What error?
This exception.
Oh, you can, on the top right of the cell, there's like 3 dots. You can say clear output.
What is torch basics now? Let's see.
It's dot torch basics. Yeah, so from fast.ai directly, I guess. Torch basics, there it is. From dot imports, dot torch imports, dot torch core. Somewhere in there, imports or torch imports probably.
Yeah. Torch basics? Probably basics, right? Oh, come on.
I think that was the one you just looked at.
Oh.
Just try that. You should get everything.
What do you mean? Try what?
Try using that import in our notebook.
Do you want to just take over? Because I feel like the lag is kind of...
Okay.
Yeah, go for it.
Okay, let me see. So what I was thinking is, yeah, if maybe we can just do from torch basics. No, that doesn't. Or from dot. Maybe it's similarly structured. No. Beyond torch, so maybe just that.
No, I don't think we have that.
You don't think that just comes with install? I mean, this is part of installing fast.ai, right? Like it's in that same repository. Am I misunderstanding that? Like my understanding is that this is saying from here dot imports, import everything. So from, I think we get all of this when we say install fast.ai, right? And so it's just saying from imports, import everything from whatever all of these things were. And then you just need to say import torch basics, and torch basics does all of these imports.
Mm-hmm. So what are we actually importing on?
I think we maybe already have it, since we're saying from fast.ai dot. Right. Okay. So we just take fastbook. So maybe we have to say from fast.ai dot. Yeah, that should work. From fast.ai dot.
Torch basics.
Torch basics, right? It's on the root level. Fast.ai dot torch. Yeah, that should work. From fast.ai dot torch basics, import everything. Yeah, okay, cool. That works.
And then it should still be copied. So if you just paste there.
Okay, so tar file dot open. And I can pass it a file name.
The file name was
there it is, archive. So content, no, one up from content. We should define this path. Give me a second. That's at tar path
and then it was
root
just
dot fast archive, and then
images.tar.
Okay,
I think that's what that should be. As, yeah.
Mm-hmm.
Yeah. So
and then let me double check that. We can say tar path dot is file. It does. Maybe underscore. Sorry. Okay.
Cool.
So okay, we gotta call it to see whether it's a file or not. Okay, fine. So it's finding this file.
Okay, cool. So now let's do tar file, open tar path.
Tar path, and now we should get the same
right
thing that we got here. Destination, let's define that one too. Or we just say doctor. So now that should make the same error we had above.
Not a
gzip file. Okay, it's a bit more.
That's fine, because this is probably what the other one's getting, and then it's returning back what the pi bait. You know what I mean? Like, it's not returning this error; it's going to return
because it's packed in a function.
Yeah,
so
they return another exception.
Yeah.
So that's fine. So cool. So let's go back into.
Do you remember where it was? Was it in where we had that?
It was 2 in, so I think it was
data. External, that's where it was. And then we can say, can you delete this? Can you block this user on the chat?
How do you do that?
I don't know. Maybe you can click and block or something. Yeah, else, raise exception, unrecognized archive, and then archive.
What if this is like our golden opportunity?
I don't. So file extract, file name, destination. So I could also do this. Because we imported that too, so we should be able to do file extract. Yep. File name would be tar path. And now we should actually get the same error as before, because now we're just calling the function which then does this in there. Unrecognized archive, there you go.
Cool.
Nice.
All right, so let's clean that up. Let's get rid of file extract.
Yeah, we don't need that.
And
then here we want to do.
Let's just test.
This.
Yeah, let's just test that like our gz, just put tar after.
r.tar. So
Let's just try it. And then if not, we'll look up the docs. Seems like it's working.
it's doing something.
We can't see it through that anyway. Because it's going to...
Why
Oh, no,
not?
it's extracting. Never mind. Yeah.
To doc directory, yeah. Should be fine.
And then under images, right?
Yeah, I mean, so this is hard now because we had this images directory already.
All right,
So
we
we're not
didn't
really
delete
seeing
it.
it.
Are we just getting double everything now? So there should be double Chihuahua, like...
I don't think so. I think it's going to override it. I think it's going to override it. If it's exactly the same names, right? But we can try this. It really seems like it's working. So I'd suggest we stop it and delete this images folder and try again.
Sure.
So let's see. Delete folder. That makes it harder.
Just do it in bash. Just remove art, yeah.
Okay. Content. No, we are in content, so we gotta do
G drive.
Come on. I mean, anyways, I can do that anyways. / content G drive. Drive. Data. Doc. Classifier. Images. Jets. Yes. I wonder how big that is. We should have checked before.
Yeah. Anyway, you want to just run the next one, and then we can start doing the RegEx.
No, I want to just first confirm that it's not here, and then that it pops back up.
Okay, I will sit still. I'll sit on my hands.
Chill, just breathe, relax. It's happening. It's all happening.
It's happening, yeah.
Maybe.
All right. So cleaning up the folder names. Do you wanna? Where do we land on that? Do you want to just normalize it with Python, or do you want to do RegEx?
Let's do RegEx. Let's use the same things that they're using.
Okay.
I have another question for you though. Like, if assuming that this actually works, I don't understand why they wouldn't just have an elif with ends with dot like tar.
Yeah, let's
tar
do it.
file that open art.
Yeah.
Our tar.
I think we would just have to look into the docs for tar file. You know, if this works, like, let's, actually make sure that, because it's done running. Because I just guessed, right? Like r:*tar, right? Maybe there's a reason why. Yeah.
Okay,
so
here we are. It's gone. Now we do this. And now I'm happy to do something else. But because it seems helpful, right? Like I mentioned that there's at least one data set that seems to be a legit machine learning data set that ends with it's in the tar.
Yeah, we could do a PR for it.
Okay.
Cool. All right, so while this is working, so we're just gonna match. We'll just take. I think we had it set up already, right? We're matching everything, and we're just taking the second group. Yeah. Cool.
I would say that would be on because this is how it lists it out, right? So there they are. Look at it.
Nice.
Looks good.
Cool. All right, so let's write our.
This is working.
Yeah.
Nice.
All right, so let's write some cleanup.
Take a note.
Or take a note. All right, I'm just gonna stop talking.
you do not have the power of clicking.
Can we work in the same notebook and see through Colab and see like?
I think this is actually possible.
Yeah.
I think we can I guess it's called Colab. So it might be possible that we can actually collaborate on it.
We should try that in a future stream.
Yeah. With what was the function name? That's in here. File extract. With this, not doctor, get it. Okay.
Cool.
Good. Is this done? It's not done, but it's doing it. Okay, so we got the RegEx, and now we can move on here. Where was it?
Right there.
There. Okay, get Y using attribute RegExLabeller. Okay, so but here we don't want to. The thing is, this takes images, right? Image files, and we're looking at folders.
So I don't know what this RegExLabeller is doing, but if you scroll up, can we not just use the regular, re.findAll, and like, isn't there something inside of the RegEx package that like does a find and replace?
Oh, yeah.
And then
sure.
using like the OS package or something.
Yeah, but that again, why not just do it with this?
Oh, yeah.
I think it makes. I also actually think it makes sense not to change the source data. We just want to pick out specific parts of the text for our labels, right? And leave the data set in the way that we get it.
So you want to copy the data set?
No, I just want to leave the data set as it is, but when we read it into our data block,
okay,
yeah,
I get what you mean.
so
I was going to change the names of the folders completely, but you do you.
Yeah, no, I just, I would say it's probably good. I don't know that, but if I would make a good practice for machine learning using data sets, I would say leave the data set as it is.
Fair
so
enough.
that it's reproducible, right?
Fair enough.
So yeah, I'd do something like this, but I'm not sure that it directly works because this operates on images and we'd be operating on the folder names. So maybe there's something we need to figure out there.
Yeah, maybe we could do another pull request for updating RegExLabeller.
I doubt, I'm pretty sure this is in there. I'm surprised that this other thing wasn't in there. Get, split, and label. Very flexible function since it handles any regex search of the stringified item. Pass match equals true, do use re.match or re.search otherwise. For instance, here's an example that replicates the previous parent label results. Match to os.path.separator, os.path.separator, 37%, RegExLabeller, word match true. Okay, this looks like, is this file names? No, this is folder names. Anyways, look.
Sorry,
but
our faces were blocking.
Oh. Freezing.
What are you showing me?
I'm showing you that this, the way that they're using RegExLabeller here in the docs is also, it seems, on a folder name.
Isn't that in a different, like if you scroll up, that's not RegExLabeller anymore.
Correct, but down here it says, for instance, here's an example that replicates the previous parent label results. So here's the parent label result.
Label, okay.
And that's functioning on the folder, picking out the 3 and the 7s. And then here you're doing the same thing and you're getting the same results. So it must also be like it's not taking the file name is what I'm saying, because the file name is a completely different number.
Mm-hmm.
But it's getting the folder name with a very simple match. Wait, actually it's getting the file name. No, here it's getting the, so it's file names, comma 3, parent level O for O in file names, file name O for O in file names. And then we're saying file names dot file names dot name. Let's just try it out. RegExLabeller. You're done?
Yep.
Cool. Okay, so do we have tar path? Yes, I can get rid. Oh well, whatever, let's leave this. Note, and this should work. This should give us the same result now. Yep.
Cool.
Clear output. And then let's try it in here. RegExLabeller. And this was used R, and then the pattern, and then I don't know what this common name is. Our pattern was this. And then we'd somewhere have to say that we only want to pick the match group, or maybe that's what it does if you define a match group.
Mm-hmm.
Let's see what this does.
I mean, you're just creating a labeler, right? Like you have to pass it.
Correct. So we need to apply. Yeah, you're right. Mm-hmm. Using attribute. Should we try that? Using attribute, but then where do I pass in the folder name? Data block.
Is that not
I don't want to do the data block.
Mm-hmm.
Here. I mean, whatever, huh?
Why not
It
just use the data block?
Yeah, it just feels like a lot in one go. That's why not, but I don't exactly know how to pick it apart right now, so. And right, like what does this name do, for example?
Mm-hmm.
Actually, using attribute.
That's I think it's just calling it the name.
Or it's doing f.name, like on a path object. I guess we could look at using attribute. File attribute, change function file to operate on attribute. So it's doing file.name, I think. No, I'm not sure. Yeah, I'm not sure at all.
Okay, well,
try.
Yeah, then, right, the data loader.
Let's just try. Path, and ours would be dog path, I think, images. Dog there.
Yeah. Dig there. Yeah, so just replace path. Yeah, there you go. You got it.
With dig there. Okay. Let's see. Pets. No. Just...
Failed to compile.
Yeah, look, it's looking at the images. It's not looking at the folder names.
Mm-hmm.
This is one level in. Let me see. It's one of those file names that it's looking at.
Right.
So we'd need to know how to tell the RegExLabeller to look at folder names instead of file names. Yes. Oh, that looks fun. Looks like they're doing a code walkthrough, maybe actually filmed.
Mm-hmm.
Not really, it's written. Okay, RegExLabeller, RegEx label item, labeling things. For labeling, you need something that takes a path and gets a label out of it. Label item with the parent folder name. No, parent label. Okay, parent name. Parent label labels everything with the name of the parent. Nothing to customize in this case, so no return function, and therefore no capital letters for the function's name. Def RegExLabeller label item with regex pet. RegExLabeller is again camel case. We need to pass in a pattern for what we are regex labeling things with. If you want to understand how stuff works, just open these notebooks like in the fast.ai lessons and experiment with them. These notebooks. So I think parent label is what it calls by default, which is why we got the names of the folders, right? And then the RegExLabeller itself is seems to be something that by default operates on the file names. Mm-hmm. So I'm wondering whether define underscore in there. Compile the pattern search in the output, and what you pass in, search whether you find it or not. That's the assertion that we're getting. That's where it's breaking for us. And otherwise return the first group 01 would be fine, I believe, because we don't have the full string, but we actually have a match group.
Mm-hmm. So isn't there something where you could just like list all the file names or all the folder names in Python, and then so I guess let's take a step back, right? Like, what are we trying to solve right now? Are we trying to fix RegExLabeller, or are we just trying to print out all the folder names in just using the first match group?
I was interested in seeing, like, applying RegExLabeller on this, but it might not be the right. Mm-hmm. Like, what I see now is that it might not actually be possible because it's not meant for that. It's meant for files, not for folders.
Yeah. So I'm thinking, like, why don't we keep this data block, like, that whole block fine, and then we just write another function and put that into get y.
Correct. That's what we should do. Agreed. And maybe we can even use the output of this and then just cut off, like, we can do parent label. We can use parent label, right? And then just change what we get back, the string we get back, by cutting off the first part.
Mm-hmm. Let's try it.
Okay, so we write a custom function, def clean folder name, and then we want to get what do we pass?
The pattern?
No, we don't. Do we even need to pass? We don't really need to pass it anything. We just call.
Oh, yeah.
Well, let me see. Let me push this. What was it? Parent label.
Mm-hmm.
Parent label, and parent label needs. I wonder how this get y propagates functions, right? So it just applies it on everything. But what do I need to put in as a as an argument here. No, that's the wrong. Where was that? All quarks. Let's just do that. Just pass it around, and then we say, so that's full name. Now we want to return full name. Let's split at the dash and get the letter, the end of it, the second part.
Mm-hmm.
Yeah. So maybe let's try. I'm not sure about this passing the arguments around, whether it works like that, but let's see. And then we give this one clean folder name. Do I need to call it? No. Get image files. Okay.
I mean, how does it know to go to? Oh, because you're passing dog down there.
Down there. It's not breaking yet. I do expect it to break, but let's see.
Honestly, like if it's running that far, it sounds like it's probably working. So let's look at our data loader.
Okay. How would that be? DLS dot what?
Oh, I don't know.
Show. Wasn't there something? We were trying something below. Image.open. That doesn't help. Go away. Functions. Get image files. We don't need. We did all of that stuff already. So we got a data loader, huh? There it is. Docs data loader. There it is. Data loader valid. All right. The moment of truth. If this works, I'm surprised. Look at that.
Nice.
Hacky.
Oh man.
This is fun. I'm pleasantly surprised.
Same.
We could even make it prettier. We could just say, like, I mean, if you want, we could split up. Now that's pretty easy. We could just replace the underscores with spaces and stuff like that.
I'm good. Let's just keep going.
Okay.
I'm happy with this right now. Because I saw one that had no underscore, but it was like two names. It seemed like it was like two names with camel case on one of the dog names. I'm like, I'm fine with that. I'm more interested, like I want to train this and see what the results are, how good theirs are versus what we were doing.
Cool.
Because right now, actually maybe we should have. So here, these dogs were doing this. Maybe we should apply that here actually instead of that other data loader, because the other data loader we're doing a different. Right, like do it here. Get y is equal to, and then replace it with what we put up there, because here we're doing this random split, and we're resizing.
But why do you not want to? Yeah, why do you not want to apply the?
Because if you, because right here we have this like batch transform, and I think we copied that in, and that's part of what they're doing differently than us, right? We got results without doing these, because this aug transforms came in the lesson after, I think, unless we're doing something further down, which is possible.
I think we actually are, like, I think we have a bunch of stuff double in here. And
there it is. Yeah.
You see there's this data augmentation.
So what's in there?
So I think we actually, let's see, where's the final?
Right there.
Random resize.
Transforms, aug transforms. DLS is equal to date. Okay. So we are doing it eventually. Okay, this needs to get cleaned up a ton.
Be my guess.
Sure. We'll put a note down. Clean up and finally finish.
This needs to
Dog
be
breed
cleaned
classifier.
again.
All right, cool.
Yeah, sweet. Interesting. So they're doing a transform resize 460. They're doing an org transform 224 minimum scale something. And so these are the two lines that might be different. So let's compare.
Yeah, but we're doing it. I think we're
doing
the
something
same,
similar.
Same. Yeah.
We're doing item transform resize.
So we're doing the random resize crop. They're doing resize.
And then we're doing org transforms the default, and they're passing in something.
So org transform default.
So it's different, yeah.
But it seems like, so for that, they're just org transform size. It looks like we're just resizing and doing the scales before. I don't know. Again, I just want to see the results of the differences. So let's keep going down on theirs.
Okay, yeah. All right.
Okay,
that
we
was
did all
a nice
this.
excursion.
Pre-sizing.
All right. You, for me?
Sure, pre-sizing. We need our images to have the same dimensions so that they can collate into tensors to be passed to the GPU. We also want to minimize the number of distinct augmentation computations we perform. The performance requirement suggests that we should, where possible, compose our augmentation transforms into fewer transforms. That's where that is, okay. To reduce the number of computations and the number of lossy operations. Transform the images into uniform sizes for more efficient processing on the GPU. The challenge is that if performed after resizing down to the augmented size, various common data augmentation transforms might introduce spurious empty zones, degrade data, or both. For instance, rotating the image by 45 degrees fills corner regions of the new bounds with emptiness, okay? Which will not teach the model anything. Many rotations and zooming operations will require interpolating to create pixels. These interpolated pixels are derived from the original image data but are still of lower quality. To work around these challenges, pre-sizing adopts two strategies. Okay, resizing the images to relative large dimensions, that is, dimensions significantly larger than the target training dimensions. I think that's where that 460 we just saw was. And compose all the common augmentation operations, including resize to the final target size, into one, which is what they're doing. And perform the combined operation on the GPU only once at the end of processing, rather than performing the operations individually and interpolating multiple times. Okay. The first step, the resize, creates images large enough that they have spare margin to allow further augmentation transforms on their inner regions without creating empty zones. This transform works by resizing to a square. Using a large crop size on the training set, the crop area is chosen randomly and the size of the crop is selected to cover the entire width and height of the image, whichever is smaller. In the next step, the GPU is used for all data augmentation, and all of the potentially destructive operations are done together with a single interpolation at the end. Okay, so this is where I actually want to stop working on ours and continue just working on theirs. Go through, like, let's do the full notebook of theirs, like this one, see what the results are, and then, because this tells me now that, like, if they're doing all of this on the GPU at once, then their model will be better than ours, because the process of how we were resizing, transforming, augmenting was done in steps, and we may have had some significant data loss or corruption or something. So let's continue with this, like, I think until the end, see the differences, and then we can, it could be during the cleanup, like, you know what I mean? Like, I could do a separate cleanup video since you've been doing them So like you've done the previous two, I could do this one where we apply fast AI's version to ours.
Cool.
Yeah. Cool. So crop full width or height, random crop and augment. Okay. So this picture shows the two steps: crop full width or height. This is an item transforms, so it's applied to each individual image before it is copied to the GPU. It's used to ensure all images are the same size on the training set. The crop area is chosen randomly. On the validation set, the center square of the image is always chosen. Okay. Random crop and augment. This is in batch transform, so it's applied to a batch all at once on the GPU, which means it's fast. On the validation set, the only resize of the final size to the final size needed for the model is done here. On the training set, the random crop and any other augmentations are done first.
So if I understand this correctly, then this one happens step by step on each image, and this happens on all of them at the same time.
Yes.
So if we would do all the cropping, etc., in the batch transform, which they're not doing either. They're doing the resize. Okay, so us doing random resized crop, for example, in the item transforms means we're potentially losing data in here. What they're doing, they're just cutting it all the same way.
Yeah, it seems like the batch transforms, this like aug transforms size and min scale. Maybe they're doing a random resize crop on the GPU, but they're getting this 460 by 460 photo before. Yeah.
All of the batches consist of only 460 photos, and then for each batch that they get in to run it on, they apply the same stuff. Mm-hmm. So the same piece gets cut out, the same augmentation gets tweaked on each of them, etc.
Yeah, it just seems like if it's 224, when you are tweaking it, you won't get those empty corners like they were saying. Because now you have a 460 by 460 image. Cool. All right. To implement this process in fast AI, you use resize as an item transform with a large size, and random resize crop as a batch transform with a smaller size. Random resize crop will be added for you if you include the min scale parameter in your so they are doing it on the GPU. They're doing random resize crop on the GPU function as was done in the data block call in the previous section. Cool. So alternatively, you can use pad or squish instead of crop, the default for the initial resize. Okay. So the bottom shows the difference between an image that has been zoomed, interpolated, rotated, and interpolated again, which is the approach used by all other deep learning libraries, shown here on the right, and the image has been zoomed and rotated as one operation and then interpolated just once on the left, the fast AI approach shown on the left. Do we have...
Wait, I just zoned out for a second. What was that?
So so there's two images, but I don't know where they are. Maybe not in the notebook, and maybe are they here? Or maybe we have to run this to get the images.
I guess not. Maybe.
Yeah. Okay.
Oh, I guess we didn't run something above. I forgot running something. Let's see. This is not. No. Oh, we ran that. Oh, that's documentation. We did run this one.
No, it's something with bears.
With bears?
Yeah.
Precising.
Yeah, scroll down. Image grizzly.
Oh.
So maybe it's... Yeah, we didn't change anything here, so... Did you run everything? From the beginning?
I thought so. Mm-hmm. I can give it a quick scan, but I'm pretty sure. Just ran, it's got a number. Ran. Maybe it's referring back to, the grizzly stuff that we did in a previous notebook. Mm-hmm. And maybe it's like assuming that this all runs in one go.
Probably, yeah.
Yeah, it's not here otherwise. DLS1.
Okay, I mean, just pick another image that we have.
Oh. So it's just assuming that we have the grizzly images.
Yeah, so just pick another
Right,
image.
Yeah. What's our path.cw? That's content. So we want to, well, should I just go into the...
I mean, go into the folder structure and just see like where we have stuff.
Well, I know we have it in dog there. And then we could get one of the regs images from there.
Did we do dogdir in this?
Yeah. No. Yes. But it's not a string. I made a mistake there. And then we can just do 7 zeros. Psychic Nick knows zeros with one look. So this is not a, this is just a dog there, and then it's just the name of the okay, to go work. Nope.
Do you need path CWD? Do you need that?
Remember, dog there is not defined. It isn't?
I don't think we defined dogdir in this one.
Oh, here. Of course not. It's a different notebook.
Yeah, so dogdir content.
Yeah. Then content,
G drive.
G drive. My drive. Data. Dog breed classifier. Okay.
And images. Oh no.
No, it's not in images actually.
Yeah. No, never mind. I saw that. Yeah.
Should be fine. Okay, yeah, there it is.
So the scroll up and let's just see what's happening. So on fast.ai's data augmentation on the left and the traditional approach on the right. So let's see, can we scroll down and just see the difference? And can you zoom in? It looks like you don't even really have to. The one on the left looks more clear.
Isn't that the traditional one?
No, that's fast.ai's.
Ah, yeah, you're right there.
And look on the right, the ball is like
Yeah, the
split
ball
into
was
two, and we both turned our heads at the same time.
Look at it.
Yeah, okay, cool.
You can access our previous root user 99. You can access our other videos on the YouTube channel. It's linked in our about on the Twitch page.
Oh, yeah.
I think we got 6 of them uploaded, and but we're gonna follow up with the next ones pretty soon. We've got some timestamps on there too, so you can click through it when we get lost with stuff if you don't want to see all the detours that we're taking.
I'll grab the link and then
cool.
send it.
Cool. So this really looks much nicer. Good job, fast.ai. Sweet. You can see that the image on the right is less well defined and has reflection padding artifacts in the bottom left corner. That's so interesting that it seems like all of the images get that, right? Because we just used a completely different image, and it seems like text is still still works. Also, the grass ayat at the top left has disappeared. Well, that doesn't really apply. Even though it does, kind of. No, it doesn't. Oh, that's a bear with some grass in the original, whatever.
Yeah.
All right. Fun though that the ball still, the bottom left corner still applies. The fast.ai library also provides simple ways to check that your data looks right before training a model, which is an extremely important step. We'll look at those next. Checking and debugging a data block. We can never just assume that our code is working perfectly. Writing a data block is just like writing a blueprint. You will get an error message if you have a syntax error somewhere in your code. but you have no guarantee that your template is going to work on your data source as you intend. So before training a model, you should always check your data. You can do this using the show batch method. Yes, we've used that before. Now we see some nice puppies. No, oh, we do actually here too. I keep mixing up which notebook we're in, whether we're in this one or the dog breed one. Where's our batch here? It's not the batch. There's our pet batch with the beautiful names. Leonberger. Do you know this dog breed, Nick?
I do not.
It looks like what's this? The ones that carry in all the cartoons carry the alcohol in the little boxes.
Is that Saint Bernard?
What's their name? Saint Bernard, right here. It looks like a.
I was gonna say it looks like a lion, but that's also because maybe I'm pulling lion from the name. This British short hair cat. My goodness, cats are always like, it's like looking at me like, do you have my food? Are you messing with me again? Are you serious?
No,
you left me with the dog.
She's just like, hi, I'm cute. Pet me.
Yeah. Evil.
Take a look. Let's not start this.
Okay.
Take a look at each image and check that each one seems to have the correct label for that breed of pet. Often data scientists work with data. So let's look at some more. Let's do 3 rows and 4 columns. And let's be good data scientists. What Google dog breeds, because I don't really know them.
All right, so the pug looks good. Basset Hound looks good. Yorkshire Terrier, okay. Scroll up a little bit. What's that one on the top right? American Pit Bull Terrier, okay. Staffordshire, but like, I guess so.
I don't know much about cat breeds. I also don't know much about dog breeds.
I think Sphinx, that seems pretty accurate. And then Keeshond, I don't know what.
You know what's interesting though is that we're not actually getting the amount that I specified. It cuts off after 8 and 9. Maybe. Do you think that like one batch could only be 9 images? It sounds really small.
I don't know.
But it looks like, show batch. And then we define, like, what if I give 4 rows? Am I still going to get the same amount? Like, it seems like it's not showing more than 9
images, right? Where did it go?
Sorry. Yeah, again, like it's just showing 9 images. So maybe
Scroll
one batch
down.
is.
Oh yeah.
It just made an additional column. Yeah, because I said 4 columns, but there weren't any pictures left to show. So if we do only 2 rows, then we never notice this.
Like good data scientists.
Like good data scientists. Yeah. So, well, we could check what's the default batch.
Anyway.
All right, let's
so
just
I think,
not.
yeah, we're... Take a look at each image. Okay, we did that. They seem pretty correct because we're professional pet breed classifiers. At this point...
I actually don't know what a lot of these pet breeds are. Yes, me neither.
I would use Google Images at this point to search for pet breed. I'm going to say I agree with most of these so far.
You're our Google image. Let's check what a Bombay cat looks like. Is it black? Yes.
Yeah. There you go. Look at those eyes.
Look at those eyes. They're really big. Saint Bernard. That's one. What was the other one called?
Leonberger.
Leonberger.
Leon.
Dog. Leon.
So pretty.
Leonberger.
Oh my goodness, look how big they are.
This is huge. Oh wow.
Look how fluffy. They're so handsome.
That's crazy. Wow. It does look like a lion. Okay. Good enough.
Burger.
Good enough.
That's probably like it sounds like it's got to be like a German name or something, right?
Berger, yeah, it could mean just something from the mountains. Like Berg means mountain.
Mm-hmm.
So,
So is that like the lion,
Berger.
the mountain lion dog?
Lion.
Yeah, maybe it was bred to hunt mountain lions,
Could be. Or it was just,
or to ward off mountain lions from the herd. Okay, now I'm more curious about that. Can you go to Wikipedia?
What do you want to? Leonberger?
Leonberger name or
All right, let's do it. Leonberger. It's a German dog breed?
Yeah, you just have to translate for us now.
Well, no. It's a giant dog.
Whose name derives from the city of Leonberger. Okay, Leonberg.
All right, that was easy. Look at those houses.
Do you live in a house like this? Does your house have all these like crisscross?
Otherwise, they don't stand. How do you make your houses stand?
Vertical lines, not so many crisscrosses.
No, you gotta go like that. It's structural stability.
Yeah. All right.
There you go. Look, according to legend, the Leonberger was ostensibly bred as a symbolic dog that would mimic the lion in the town coat of arms.
So not what I was thinking. So
Well,
not to hunt mountain lions.
No, I told you there's no mountain lions in Europe, so you wouldn't really get a big chance to hunt them. There's the lion that it's meant to represent. Yes, we don't have that big anymore. Our biggest would be a wolf, cats? I guess. Wolves? No, we don't have big cats. Like the lynx is the biggest cat that we have in Europe.
Okay.
Which is arguably not big.
The more you know. All right.
The more you know, the less you know. The more you know, the less you know.
All right, let's run this.
What are we running? This.
Yeah.
Oh no. Pipeline failure. Because now no, that should work.
What's the error?
What's your problem? Blocks, image block, category block. Okay, so what is it saying? If you made a mistake while building your data block, it's very likely you won't see it before it's step. To debug this, we encourage you to use the summary method. We'll attempt to create a batch from the source you give it with a lot of details. Also, if it fails, you will see exactly at which point the error happens, and the library will give you some help. For instance, one common mistake is to forget to use a resize transform, so you end up with pictures of different sizes, and you're not able to batch them. Here's what the summary would look like in that case. Not that the exact text may have changed since the time of writing, but it will give you an idea.
Yeah, okay. So
blog, image block, get images, get image files, splitter, get Y, do this stuff.
So we're doing a summary on the data block, and what's the issue?
Setting up. There you go. Time error. Expects each tensor to be equal size, but got the. Okay, so this is an example error, right?
Yeah, it says it a bit more. Like if you stop 1 second, scroll up a little bit. I mean that it says it right there as well. But this like pill image mode, 375 by 500, and then there was another one that had a different, I think.
Yeah, let's look at this for a second to follow what it did. Setting up transform pipelines, collecting items from this data set, found these items, 2 data sets, different size amounts, create. All right, building a sample, take this one image. Okay, partial gives. Setting up after item to tensor. Float, building a batch. And then it's applying the batch, trying to apply the no before batch transform. That's if we're not doing the resize, then it's no before batch transform, and that's why we get an error. Okay.
Yeah, and then
And it's just giving us the error message. Yeah. And it's just telling us that it gets different sizes for the images. And that must be because we're using here one, so he didn't apply there's no, in the original one we applied the
og something.
Where is
it? Further
scroll.
Right there.
Keep scroll.
Right.
There it is.
Og transform.
Item transform. I think it's that one. That's the one that we need to do beforehand so that we can apply the batch transforms.
Okay.
Yeah, and because that's missing, so probably if we add this one, then this will work, which is probably what we're gonna do if we keep scrolling. So let's try that first. You can see how we gathered the data from a file name to a sample. Then
now it's saying to learn. So I mean you can, but the DLS is gonna be, unless they did a different data loader for this one.
So let's try it.
Pets one. Yeah, it's not even using the same data loader at the bottom.
Yeah.
So if you want to just run the bottom one first and start letting it train, and then we can go back up here and fix this.
Okay. Well, we can't, because while it's training, we can't run anything.
Oh, okay.
Well, let me do that. Please, Nick.
Yeah, go for it.
Yay, see? No error.
Cool.
Because now I was able to put them all together into a batch. Makes sense. Okay. Once you think your data looks right, we generally recommend the next step should be using to train a simple model. We often see people put off the training of an actual model for fire.
I was waiting for Regs to start howling. Let me lower my mic volume. All right. Let's fine tune this one. Let's start learning.
We're learning something, finally. Isn't it? As we briefly discussed before, the table shown when we fit the model shows up the results after each epoch of training. Remember, an epoch is one complete pass through all the images of the data. The columns shown are the average loss over the items of the training set, the loss of the validation set, and any metrics that were requested, in this case, the error rate. Remember that loss is whatever function we decided to use to optimize the parameters for our model. We haven't actually told fast.ai what loss function we want to use. So what is it doing? Oh, remember last stream we were discussing about why is there no loss function? And then we were like hunting down where's the default loss function. And where is it defined? Here they're telling us about it. fast.ai will generally try to select an appropriate loss function based on what kind of data model you're using. In this case, we have image data, and the categorical outcomes of fast.ai will default to using cross entropy loss. Pretty cool. Cross entropy loss for you.
Sure. Cross entropy loss is a loss function that is similar to the one we used in the previous chapter, but as we'll see, has two benefits. It works even when our dependent variable has more than two categories. It results in faster, more reliable training. Okay, in order to understand how cross entropy loss works for dependent variables with more than two categories, we first have to understand what the actual data and activations that are seen by the loss function look like. Okay, so viewing activations and labels. Let's take a look at the activations of our model. To actually get a batch of real data from our data loaders, we can use the one batch method.
Now
it's not going to be able to run anyway.
Yeah, you're right, because it's still doing. But now we can figure out whether it's actually 9 images. We can just get the length of X, I guess, and then we should see, or the length of Y.
Yeah.
Either way.
All right, scroll up a little bit. How many? It didn't say how many epochs it's training for, right? Like the dot fit.
Two. Fine tune.
Fine tune.
So what did we learn last time?
I'm just gonna run to the bathroom. Just like seeing that this is gonna take another minute. So.
Okay.
Okay.
Goodbye.
Be right back.
Have a nice day. I shall twist and turn on my stool. In the meantime, or do something useful, but probably not. Intermission. Turns. What is this thing called? Okay, I can actually recap this for myself because I was interested. What does fine tune to was the amount of epochs that it runs after. And then we could pass in freeze epochs, which means that it would train it on the frozen, like that it takes the resin at 34 and trains on all of the, that's two, so right, there you go. So just, if we would add freeze epochs here and a number, then it would train first those, like just without changing the any of the weights within ResNet, but just train on the last two extra epochs that we're adding with our data, and then it would unfreeze it and do 2 epochs on the whole data set. So with all of the layers unfrozen. We're not freezing anything, so it's just doing the training on the unfrozen from start to finish, all full model, whatever this is called, something like that. And we got our results. I got an accuracy of error rate of 0.07, so 93% of the times it's correct. Did I read this already? Yes, cross entropy loss. Let's look at activations of our model. One batch. Okay, so now I can play around with this thing that Nick is anyways not very interested in. I want to know if this is 964. Okay, that is then confusing why I would before not show all of them. Let's look at a few. Tensor category. Interesting. So it gives them, that's the labels. The labels are actually just numbers. And these are our images. But for some reason, it's actually not using, it's not using any names of the images, but it's using some, hi Nick. So I bet it's 64, it's not 9. So I'm not sure why before it was only showing 9 images. And also another interesting thing is that the labels here are actually numbers. I'm not sure, maybe the categories get mapped to the actual names somewhere else and are internally represented as numbers. But yeah, so this is one thing. And then the other thing was the length of one batch is 64, not 9. Yeah, 9 sounds really small.
Interesting.
So
what's just out of curiosity is, like, what do those numbers mean, right? Are there, can you run max on Y? See what the highest number is?
Only show, just a second. Maximum of 9 images. It's one question. And here, what are these numbers? Do they map to names? Oh, hold on. And you wanted to know what is the maximum? No, not text. Go away. Code. X. Y. 36.
So there's repeating numbers in there.
Yeah, well, I think it's just the labels. You know, like this is one batch, and like at the I guess we could check. Do you have the repeating number?
No, okay, I'm just thinking if there's 36.
How does that go?
Well,
like we could pick out 2 of them and then just look at the images and see whether the ones that have the same label. I mean, it should be. If there's a 9 and there's another 9, they should both be.
Sure. I mean, you could loop through this and just count, or just pick a number.
Yeah, that would
right?
be
9. If there's.
I guess the dot count is not implemented on a tensor category object, but I could say list. Probably 1. Okay, so that's not a good one. But yeah, I could.
Yeah. Okay.
And then I think you can
like good data scientists.
Index. How's that? Or maybe it's actually index.
So it's just grabbing the first one. Just do list.
Yeah, that works.
Yeah. Like after, like y.
I think you can probably do something like start. All right, I'm just.
You're just guessing.
I am guessing this out of my behind. Yeah.
Why don't you create? Can you not create a list?
Yeah, of course I can.
No.
No, what do you want?
Like, okay.
You want something more.
Hold on.
More elegant.
Can I?
You want to do it?
Let me write some Python. Yeah.
Yeah, do it. I mean, you could also look up what's the right way of getting the index of all of the items. What's that? What are you doing?
Oops.
What's that supposed to be?
Why is it? Oh, can you put Y, because my Y is mapped to your Z on my keyboard.
You're tapping too.
There. So there you go. So 61. So it's index 1 and 61.
Well,
and those are the two in this case.
Cool. So which means we could get the x's, like we could say im1 equals x1,
right.
And image 2 would be x61, and then we could look at them. And they should be the same. im1.show, does that work? Hi there.
It's terrifying.
But it's after some sort of transform, I think. Which makes sense. Yeah, it's kind of creepy. im2 show.
So it shouldn't be the same image, it's the same dog, and it's clearly not the same dog.
It's clearly not the same dog. Well, you know what? You said make a new list and then get the index from that list, but we have to add whatever you're cutting
so add 2.
there. Yeah, so that would be...
Or add 3.
Is 0, 1, 2, and then it's starting from up to but not including, so it takes the 2, 0, 1, 2, so this one is already in there. So we actually have to just add 2, yeah. So it would be 61 plus 2. And then just like good data scientists, huh? All right.
That looks more believable.
Yeah, I buy it.
Yeah.
That could be correct. Okay, so
but
you
hold on, let's also
when
though.
you go clean up this notebook, could you just like make
yeah. So the other
into
hold on. The other thing that
we're gonna
I want to just test something, because these actually look. Whoops. They actually look like, maybe not the same dog, but the same. It's got that like blue augmentation. So I'm thinking maybe the number relates to some sort of. So clipping input data to valid range for imshow with RGB data, 0 for floats for integers. So I'm thinking maybe it's so 61 in here would actually be 59. Right?
What?
So hold on, let me just a 59 25. So
What are you doing?
two. Okay. So the first so 59, and then it goes up to 61. So we're counting 25, and then
I have no idea what you're doing right now. Can you
I know, hold on.
lay out your brain for a second?
Index 25. So 59 is the first one. So if I do, I'm just gonna do, whoops.
You're just gonna do it.
I'm just gonna do
We're
it.
not gonna talk about it. You're just gonna do it. It's just gonna happen.
Can you put the letter Y in there?
My pleasure.
Thank you.
What's that code? What's it called? Collaborative coding.
Can I not do this? Oh, whoops.
Now you have to make a.
No, okay, cool. So 60, so 59 plus, well, let me just check this. So is
I
this
still don't understand what you're doing.
0? Okay, so 0 and then 1, 2. So it should be on, so it should be on 59 and then plus 2. So it should be actually index 2. So if it starts on 60, is it 62 or 63? I'm just gonna test it out. So let's do this,
Okay.
and then oops, list. Can you put the letter Y in there, please? $25. Okay, so 62 and 25. What was it? Show image? Oh no, just show. Whoops. You're gonna have to put a Y in there at some point, but hold on. I just need the Y. I'll clean
Keep
it.
Keep it.
59. Dot show.
I think.
How did you set it up? Image 1. Okay. All right. Okay.
That shouldn't make a difference.
It shouldn't, right?
Mm-mm.
What is X? Oh, XY. That's why.
Yeah, I want to get it from X.
So my
I
guess
might only
is that it could be the same dog, but it could also just be the same augmentation. Because in this case, yes, they're both orange, but like the high saturation and everything, you know what I mean? Like this one's very blue and this one's very blue. So I wonder if the numbers correlate to the type of augmentation, not the breed.
what would that be about though?
No idea.
Like-
I'm just making connections.
So I hear what you're saying. I think though, like generally, it's always like, so this would be a label because Y's are always labels, right? Or I think generally Y's are used as labels. X is used as data, Y is used as labels. Oh, all right. Bye. Have a nice day still. Thanks for tuning in and for trolling us about the missing audio.
Yeah. So
so what I just think is like X is data, Y is labels. That's just like generally how stuff is applied, right?
mm-hmm.
So why would we have labels for the types of transform?
I don't know.
Okay, cool.
It could just be that both of these happen to be like, again, they could be the same dog breed, where the right, because like the face on the first one is very round still, and like the ears you can sort of see. But I'm also thinking, you know, the augmentation is very similar too.
Yeah.
In both of the cases.
Yeah.
So it could just be a coincidence. So anyway, let's keep going and maybe we'll get our answers. Each row is a single tensor between 136 and 37 possible pet breeds. Wonderful. So thank you all for tuning in. So good.
At least in this case, it wasn't just me not scrolling down.
At least now it was me. Yeah. Oh man. All right. Each row is a single tensor. So interesting. So what's interesting here is 37 possible pet breeds. On our Stanford set, there was like 100 plus different dog breeds. Here there are only 67 pet breeds, or 64 pet breeds.
No, 37.
37 pet breeds.
Okay. Yeah.
But why is it 64?
That's just the size of one batch. Our batch size is 64.
All right, whatever.
No, like it trains on individual batches. So, well, we still haven't solved is why show batch only shows a maximum of 9 images.
I don't know.
I think I maybe just solved it. Let me test this before reading.
Can we scroll first?
Yeah, I'm scrolling.
Other way.
No, it's not like maybe it's just the columns. Like it's not in the rows, but it's in the columns. Maybe it's like.
So you put 5. We should get 10. Well. Yeah. Then we should already have more than 9. Nope.
1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Yeah. All right. That wasn't it.
At least your experiment was quicker than mine. All right. You read. Right. You read now.
Okay. As you see, this returns the dependent as a mini batch. Let's see what actually contained in our dependent variable y. We just read that. It's a bunch of it. That's exactly what we did.
We could have also just done that and then see where which ones are repeating.
Oh yeah, but we'd have to count. It's boring. Random setting 7 pet breeds learner. This function either takes a data set index 0. I think it's fun that we learn in this way, experimenting a lot, and I think it helps. I think we're actually like very practically, not just reading over the notebook, but what all of the forum thinks and what Jeremy also says, just experiment with the code as much as you can. I think that's what we're doing.
Well, that was the whole thing when we were like looking at that huge data set of code reviews, right? We were the first portion of analysis is exploration, right? We have to make sense of it.
Yeah,
We have
totally.
to like mess around with it. So
Yeah, it's just data exploration.
yeah,
And our whole learning process here is fast.ai exploration, I guess.
slowly, we're like very slow, fast AI.
Slow AI. This function either takes a data set index 0 for train and 1 for valid, or an iterator of batches. Thus, we can pass it a simple list with our batch to get our predictions. It returns predictions and targets by default, but since we already have the targets, we can effectively ignore them by assigning to the special variable.
We should clean up all of these Jupyter notebooks and remove all the explanations and call it slow AI, impractical deep learning for coders, and then you just have to like find it all out yourself. It's just a big puzzle.
I like that. We should do that. Let's make a note. Text. Task. Remove all. I'm gonna say new course.
Impractical deep learning for coders.
It's still deep learning.
Yeah, that stays the same. We're still deep learning. We're just not explaining anything.
Right?
Yeah.
That's
It's essentially it. Yeah.
From slow AI import star. Okay, the actual predictions are 37 probabilities between 0 and 1, which add up to 1 in total. Okay. These ones. Let's see. Length predictions, sum 37, and they add up to 1. To transform the activations of our model into predictions like this, we use something called the softmax activation function. Nick. This still keeps going for a while. What do you say about splitting it up into next time?
Yeah, so let's split it up to next time. I think this is a good drop-off point. And we will next time continue on this. So we'll finish this up. We'll finish up the fast AI pet breed classifier.
Yeah.
Oh man.
Oh, that's all the things you can do with deep learning, huh? Who would have thought?
I mean, you probably can, creating like new breeds and anyway, whatever. You know what I mean. Yeah, so let's end it here. Let's finish this off next time, and then either the next time or whoa.
Oh, I shouldn't have done that, huh?
It's okay. Now it's like, look at,
mess up
do you
everything.
see the stream? It's just my giant face. But I fixed it. Yeah, so let's end it here. Review that stuff next time, and then maybe it sounds like the time after that we'll probably clean up ours and clean it up. Yeah.
Yeah. That sounds good.
All right.
There's absolutely no need to be one video per one lesson. I think that's a bit.
It's definitely a bit, yeah.
Definitely not our learning speed for it in the way that we're going about this. So.
No, I don't think so.
Okay.
All right.
Cool. That was fun.
Yep. And I guess we'll see you guys next time.
All right. Bye-bye.
Bye-bye.